I want to give myself glowing eyes. Why is this what I'm spending my time on? I mean, come on, it's pretty cool. This is a firefly. It uses luciferin to make it glow at night. Ever since I've heard of luciferin, I've always wanted to stick it in my eyes to make them glow. Now obviously, I'm not actually going to stick this in my eyes. Not only would this be super expensive to make, but it's also pretty dangerous. Best case scenario, you go blind. Worst case scenario, you have an allergic reaction and die. So don't do this at home. Okay, so how exactly will this work? Well, fireflies use a substance called luciferin and an enzyme called luciferase to make light. Now, it turns out that we don't actually have any idea how fireflies make luciferin. Luckily, our old buddy fungi has a solution. This is Neonothopanthus gardneri. It glows a nice festive green, and we know exactly how it makes its luciferin. Unfortunately, this means my original plan to make my eyes glow bright red is out the window. Oh well, I guess green works. So we figured out how we're gonna do the glowing part, but how are we gonna control what glows? I do not want to be a human nightlight, so we better find a way to make sure this only works in my irises. Well, that isn't easy, but it is doable. Using a special piece of RNA called the trapsime, we can detect if certain genes are active and use that to figure out what part of the body we're in. Now, there isn't a single gene that's only active in the iris, but I was able to find 2 genes that we can use together to isolate our gene to the iris. First things first, we're going to need a development environment to build this in. I decided to use Cadbury and Gill since it's my project, it's open source, and I think it helps me wrap my head around biology. After starting Cadbury, open a new VS Code window in the project directory. I've already collected all the genes and trapsimes into the file elements.gil, which is in the GitHub that I've linked in the description. First things first, set the target to human and import the elements file. Next, call the opticin operation on Neonothopanus CPH, HISPH, and NNH3H. After that, we have to set up the detector sequences. Detect per1 detects the protein per1, which is high at night. Detect RAX detects the RAX transcription factor, which we'll use to make sure our gene isn't active in the retina. Because that would be bad. Now it's time for the glowy bit. I'm going to call the opticin operation one last time, and that's where our luciferase gene will go. First things first, add in trapsime 1. Trapsime 1 cuts trapsime 2's anti-attenuator sequence if it detects per1 in the cell. Since we want our protein to only be produced at night when per1 is high, we'll use trapsime 2 to cut the protein if its anti-attenuator sequence wasn't cut. Now, we want to make sure that all of our components are free to move around and interact with each other properly, so we'll add poly A40, which is a sequence which adds 40 adenosine nucleotides to separate each of the components. Finally, we'll add trapsime 3 and one more separator to detect RAX to find out if the gene is in the retina. So all we have to do now is add Neonothopanus LUC, the luciferase gene, and we're done. Wow, that was both incredibly rewarding and also a total pain. I had to design each of those trapsimes from scratch, and that takes about 30 minutes to an hour each. If I ever do something like this again, I am 100% writing an operation to make the trapsimes for me. Still, I feel like I learned a lot. I always go into one of these projects thinking it'll be super easy, and then before long I realized that it's actually a lot harder than I expected. I think that's why I love these projects. Not only are they super cool, but I also learn a ton. The project's GitHub is linked in the description, so feel free to check it out. With that said, peace.